Let's go ahead and take an example of a problem that's asking us to solve for a right triangle. So what that means is we want to find all the missing or the unknown side lanes and also the measurement of all the unknown angles. And in order for us to do that, we have to make sure that those two conditions are true. So since we know the length of two of the sides, we're able to find what that third side is. And to do that, we're going to use the most famous theorem that we have to find the missing side of a right triangle, which is our Pythagorean theorem. So if you recall what the Pythagorean theorem is we square our two legs, and it's going to equal to our hypotenuse square, which is C in this case. I'm going to go ahead and assign A and B to those lanes. It doesn't matter which one you assign to A or B, because they're both your legs. You're going to square them, you're going to add them together. Let's go ahead and simplify the expression that we have here, or the equation that we have here. So squaring our legs gives us that. We are going to sum them up. And then we don't want c squared, we're looking for c, so take the square root of both sides. And that gives you approximately 3.6. And we are going to be turning it into decimal form just because we might be using it for a trig ratio later on. Or not. So C is 3.6. All right, we have found the length of all the sides. So now we're going to go ahead and move on to find the measurement of the two acute angles. So that would be angle A or angle B. Doesn't matter which one you start with. I'm just going to do it alphabetically, so I'm going to go ahead and start with angle A. We know that to angle A, those two sides, one of them is the adjacent side, the side that's labeled as 3 is your opposite side. So we're going to use SOHCAHTOA to determine which trig function I'm going to use to make a trig ratio. And since we have the length for all three sides, it doesn't really matter which one you're going to use, but the ones that I'm using is 3 and 2, which is the opposite and adjacent. That means we're going to be using tangent. So this is what my ratio looks like. Tangent of A is the opposite, which is 3, over the adjacent, which is 2. And to make my calculations even easier to type into my calculator, I'm going to turn that fraction into a decimal, which is 1.5. And then you just learned how to find the measurements of angles by taking the inverse. So if I take the inverse of tangent, that leaves my angle A alone. So that means that angle A will be equal to tangent inverse of 1.5, which is approximately 56.3 degrees. And then what you want to do is you want to be doing this on your own calculators as well to verify that you know how to find these measurements and you're verifying that your answer is the same that I'm getting. All right, so we're going to go ahead and find angle B. You can set up another trig ratio to find angle B, but there's an easier way. Since we know the measurement of two of the angles, we know all the angles sum up to 180. So if I subtract the two angles that I know, then I could just find the measurement of the remaining angle. So the measurement of angle B is approximately 33.7. So you have solved the entire triangle since you found the measurement of all the three sides and the measurement of the three angles.